We'll revise chapter number 9, ray optics. We'll start with focal length. Focal length, too many formulas are there for focal length. At first, we'll start with mirror. For mirror, focal length is given by, I'm writing down the reciprocal. 1 by f is equal to 1 by u plus 1 by v. For mirror, this is the formula. And if it is lens, for lens, it is 1 by f is equal to minus 1 by u plus 1 by v. If it is a concave mirror, concave, okay, this when there is a cave, always remember the answer always will be negative, whether it is a concave mirror or concave lens. Concave mirror, for concave mirror, and for concave lens, if it is a cave, remember it always will be negative. So focal length for concave mirror or concave lens, focal length is always negative. Now let's see for convex lens. For convex lens, when it is a vex, remember it always will be positive. So focal length is positive for convex lens and convex mirror. So for convex mirror and convex lens, focal length is always positive. For concave mirror and concave lens, focal length is always negative. Other than this, we have a formula for lens also, or the formula is 1 by f is equal to n2 minus n1 by n1 into bracket 1 by r1 minus 1 by r2. This is a formula when the two radii of curvature are different for a lens. Okay, you can use this formula for convex lens and concave lens, by concave lens, plano concave lens. Okay, for all the lenses this formula will be applicable. Now let's see its unit. The unit of focal length. See, I have written here the reciprocals of focal length. Actually we have to write f. So reciprocals of focal length is 1 by f. So focal length unit is, it is actually a length, so obviously it will be meter. Meter is the unit is meter, and dimensional formula will be just L1. Power of lens. Power is defined as the reciprocal of focal length. P is equal to 1 by f. This is a formula for power. Its unit is a diopter. Actually, this name comes from the book of Kepler, written in 1611, along with Galileo's help. So, unit of power of lens is diopter. Its dimensional formula will be L minus 1, length inverse. For concave lens, again, for concave lens, power is always negative. If it is convex, power is always positive. Other than this, if there is a combination of lens, we can write P is equal to P1 plus P2 up to Pn. If too many numbers of lens are kept in series, then P is equal to P1 plus P2 up to Pn. So this is all about power of lens. Next, magnification. Very important. Magnification. The formula of magnification is M is equal to Hi by Ho, height of image by height of object, is equal to minus V by U if it is mirror. M is equal to plus V by U if it is lens. Magnification M is equal to 1 plus D by F for, this is for simple microscope. Simple microscope is a kind of convex lens. So for a simple microscope, M is equal to 1 plus D by F. Also M is equal to D by F. There are two formulas for magnification of simple microscope. This formula is used when the image is formed at near distance, and this is used when it is formed at infinity, far distance, at infinity. If image is formed at infinity, we are using M is equal to D by F. If it is near distance, we are using 1 plus D by F. If it is a compound microscope, compound microscope, then magnification becomes magnification of objective lens into magnification of eyepiece. If you put the values of MO, the value of MO is L by FO, LAFO, and this is ME is equal, you can remember it like L is equal to L by FO, that is LAFO, L in numerator, FO in denominator. ME is either 1 plus D by FE or ME is equal to just D by FE. There are two formulas for magnification of eyepiece, 1 plus D by FE and ME is equal to D by FE. If we multiply these two, we get one formula, M is equal to L by FO 1 plus D by FE. This is the formula for magnification of microscope. Also, if we multiply these two, we will get M is equal to LD by FOFE. This also is the formula for magnification. Generally, we use this formula when it is a near point of vision. This is for near point. This is for image at infinity. For telescope, magnification is given by M is equal to FO by FE, where FO plus FE is called tube length, L of the telescope. For combination of lenses, magnification is given by M is equal to MO into ME, M1 into M2 into M3 up to Mn. So in case of lens, okay, series connection of lens, magnification always multiplies. Okay, so this we forgot the unit. The unit of magnification, see, it is actually the ratio of height of image to the height of object, or we can say V by U. It is unitless. And dimensionless. Okay, so this was some of the important formulas of chapter number 9. I hope you enjoyed. Keep watching. Thanks.